Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Then we would start right away. Let me just turn on my preview screen so that I know that I'm visible or not. Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible? Hi Sanjay, how are you? This session would start at 3 p.m. IST and it's 3:01 and we have started with a delay of 20 seconds. That is because when I come live, this thing comes to you after a time period of 20 seconds. Fair enough. Let me just again do that. Yeah. Okay. So can I have a quick +1 that I'm visible as well as equally audible? Then we would start right away. Okay. So today we would be doing yesterday's problem of the day, that is coins of Geekland. This question appeared in Adobe and this question is of matrix and arrays itself. Now this question has a quite good success percentage, that is 72%, and this is a medium level problem. Now let us read and understand the problem statement correctly. So in this problem statement we are given a matrix. Okay, we are given a matrix of n cross m. N cross m means that there would be n rows and m columns, and you have to find the maximum sum of coins in any subgrid of size k into k, okay, where k would be less than equal to n cross n. Okay, so you need to find the maximum sum of coins. Sum of means addition of, in any subgrid. Suppose there is a big array and you take a part of it, then it is known as subarray. The same thing here also means the same, that we take any subgrid. Subgrid means any submatrix of k cross k. Coins of negative denomination are also possible at Geekland. This means that it is not the case that every time the coin denomination would be positive only. It might be the case that the coin denomination might be negative. Okay, so now let me give you a better example out of this. So suppose this is the given matrix of n cross m. Okay, this is the given matrix. Now in this matrix, if I draw a k into k, okay, like this, and I take like this and I keep it here. Okay, suppose I take a matrix at this point and I keep it at this. So if this is the case, then this would be my submatrix. If this is my case, this would be my submatrix. Okay, it might be the case that the k into k is like this. Okay, we can do like this, or what we can do like this is we can have a portion out of it like this, and the sum should be maximum. Okay, sum should be maximum. Okay, fair enough. This is how we need to proceed. Now if you just clearly observe this, okay, if you just clearly observe, then it is told that 8 4 5 8 4, just let me remove this. Yeah, it is telling us that the numbers 8, okay, 4 5 and 6 4 5, and then 7 4 and 5, this matrix they are taking into consideration. Okay, this matrix they are taking into consideration. Now we want something like this. Suppose we have a1, a2, a3, a4, a5, a6. Okay, fair enough. Then suppose we want the sum of 3 numbers every time. Okay, so we can have something like this. Okay, then what we need to do is we need the sum of a1, a2 and a3, then a2, a3 and a4, then a3, a4 and a5, then a4, a5 and a6. Okay, same thing it can be done like this. Suppose this is the whole matrix. Okay, let us suppose that this is the whole matrix. Okay, suppose this is the whole matrix. Okay, now I need to draw a rectangle k cross k. Okay, suppose this is k cross k. Okay, and this is n cross n itself. Okay, now what I can do is I want the sum at this position. Okay, at this position, then I want the sum 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 at this position. Now the sum would be like this, the sum would be like this, then the sum would be like this, then the sum would be like this, then like this, like this, like this, and this would continue. We don't need to compute the sum every time. Okay, we don't need to do that. Okay, like एक point पे खड़े हो जाओ and we would calculate all the possible k into k matrix sum and we take out the maximum amount of it and we say to you that is not feasible. Why? Because for each cases we would be doing n square number of iterations. Okay, so for n square we would be doing n to the power 4 number of iterations. So in this we would be iterating on all the elements, and the number of elements are n cross n, it is n square. So the number of iterations would be n square. Okay, we are not talking about the time complexity now itself. We would be talking about the time complexity as we proceed forward. Okay, fair enough. Now let's just copy this sample test case and we would see to it what we can do. Okay, so let's just copy this one, add to the current page, then we would take out this and we would move forward to the further explanation. So what we can do is, if we subsequently or we again and again want the sum of a particular thing, we need to use something known as prefix sum. Okay, something known as prefix sum. Okay, we need to use this. Okay, now how to do 2D prefix sum, because the array is a 2D array, so we need to do 2D prefix sum. Now how to do in this scenario? Okay, so let me first paste the given sample test case. This is the given sample test case and these are the indices 0, 1, 2, 3 and 4. 1, 2, 3, 4. Okay, sorry, this should also be 0 index. 0, 1, 2, 3 and 4. This is done. Now we would build a, this is 5 cross 5, so we would take a matrix of 6 cross 6. Okay, 6 cross 6. Okay, 1, 2, 3, 4, 5 and 6. Okay, 1, 2, 3, 4, 5, 6. Now we have some 1, 2, 3, 4, 5, 6. Okay, fair enough. Then we have the indices as 0, 0, 1, 2, 3, 4 and 5. Then we have 0, 1, 2, 3, 4 and 5. We have this sliding window is same, but see, if that was the case that we wanted the largest sub-array sum, then the sliding window would have worked. But in this scenario, sliding window is something like this. We need to slide like this. If that is only the case, we can do that. But after going from here to here, we need to go down also. In that scenario, we want the 2D prefix sum. Okay, sliding window is like this. It goes only one direction. Either it can go in this direction or it can go in this direction. But in this scenario, we need to go down to. That is the thing where we need the prefix sum. Okay. Now in prefix sum, what we need to do is we need to fill all these values with 0. Okay, all these values with 0. Now, the prefix sum tells us the sum from, suppose at this point it would tell the sum of these all things. Okay, at this point it would tell us the sum of all these things. At this point it would tell us the sum of all these. At this point it would tell the sum of the whole array. Okay, so this is the point itself. Okay, this is the point itself. So what we need to do is we need the, suppose we want this sum. Okay, we want this sum to be added. Okay, and we already have these two sum. Okay, so what we can do is we can take up the sum of these all things. See, we can take up the sum of these all, and we can again take up the sum of these all. But first let us do this plus this. Okay, so 0 plus 0 is equals to 0. 0 plus what? The same value itself, 6. Subtracted. Why subtract? Because what happens in this scenario is, I would tell you, see, if we are taking the upper part, okay, we are taking the upper, suppose we want the sum till this point, and we are taking the sum till this point, and we are also taking the sum till this point. So this point is getting added to, getting subtracted from our sum twice. Okay, see, एक बार इस साइड से ये वाला, this is getting cut once, and again if we cut this is getting cut twice. So if this is getting twice, okay, this is getting twice, but we want the sum once, what we can do is we can just add this again. Okay, so we want the sum till this point, and we add this again. Okay, why? Because this is getting subtracted twice. So this element plus this element subtracted this element. Okay, so we can say that prefix of I and j is equal to a of I of j. Okay, okay, let me write it clearly. Okay, or let us just observe this. Okay, so we are adding this part, we are adding this part. Okay, so a of ij is equal to a of prefix of ij is equal to a of ij, this one plus these two values. Okay, a of I minus 1 dash j, prefix of, okay, plus prefix of I dash j minus 1. Okay, and we subtract the value of a of I minus 1 dash j minus 1, prefix of. Okay, matlab we are adding the top value, as this value is getting subtracted twice, so we are just adding once. Okay, now you can just fill the remaining values. Okay, so let us just fill one or two more values. Okay, so let me just clear this also. Yeah, now it should be clear. Okay, 0 plus 0. Okay, 0 plus 0 minus 0 is equals to 0 only, and we have 1, so we would just write here 1. Okay, then we come here, so 1 plus 1 plus 0 is equals to 2. 2 minus 0 is equals to 2 only. Okay, fair enough, we proceed forward. Then we have 1 plus these 2 minus 0 plus 0 minus 0, so we have 3. Let's fill the lower values so that we have a proper understanding. So this value would be 2 plus 1, that is 3. 3 minus 0 is equals to 3, so this would be like this. Okay, then this value 2 plus 5, 2 plus 5 is equals to 7, 7 minus 1 is equals to 6 itself. Now this value, okay, 2 plus 3 is equals to 5, 5 plus 6 is equals to 11, 11 minus 2 is equals to 9 itself. This is how you can fill the remaining values. Now this both is 2D array and the prefix sum is created. If you want me to fill any more values, just let me know, I would fill them. But till this point and this equation, did you understand that or not? Okay, just quickly tell me. Then we would talk about how to compute the result. Quickly tell me if you have understood what I wanted to tell you or not. Just see the equation. First the original value that is there, then the top value, then the left value, then the diagonal value. Can you please fill again? Yeah, why not? Let us fill again. Okay, this is 2, 3, that would be 1, 3. Okay, 1 and 3. Yeah. Okay, so this is the second. So we need to fill this value first. Okay, so 3 plus 0 is equals to 3. Okay, and we have a 1, that is 4. 4 minus 0 is equals to 4. Okay, so 1, and we have this value. So 4 plus 0 is equals to 4. 4 plus 1 is equals to 5. 5 minus diagonal value, that is 0, is equals to 5 itself. Then the lower value is 9 plus 4, that is 13. 13 plus 2 is equals to 15. 15 minus 3 is equals to 12. Now if you just wanted to confirm, then to confirm this we have 1 plus 1 plus 2, 1 plus 1, that is 4. Then 4 plus 8 is equals to 12. So we have the values of all these terms. Okay. Now tell me if you have understood this or not. Thank you, Sanjay. Chirag Goel, did you understand this or not? Okay. Now, suppose we are at this position. Okay. Suppose we calculated. Okay, let me just try to visualize this. Okay. Suppose at any point if we touch, suppose we touch this point, then this point would tell us the sum from this to this. Tell us the sum from this to this. Okay, we have this. Now what we can do is, we need to, suppose we want the sum only till this point. Okay, only till this and this. So only till this point only. We want the sum till this point. Okay, we want the sum till this point. Now we need to cancel out this side. Okay, what we can do is, we need to cancel out. So we would just cancel out. Okay, we would cancel out this side. Okay, and this can be, suppose this is a of I and j, suppose this is p of I and j, so this would be what? I minus k. This is of k size, so this would be I minus k of j. This would tell me the sum till that point. Okay, fair enough. Now I want this sum to be excluded, so what I would do is, I would take out the sum from this part also. Okay, and this part can be taken out by p of I and j minus k itself. This can be easily done like this, because एक x कोऑर्डिनेट पे कम हो रहा है, एक y कोऑर्डिनेट पे कम हो रहा है, एक x कोऑर्डिनेट पे कम हो रहा है. सो यहाँ तक मतलब ये सारा पार्ट का यहाँ आ जाएगा. सो वी वुड सब्ट्रैक्ट x कोऑर्डिनेट एंड यहाँ वाला पूरा पार्ट would come under y coordinate. So यहाँ वाला पूरा पार्ट y coordinate के अंदर चला गया. Fair enough. Now we can see that this part have been shaded twice. इस तरफ से भी शेड हो गया, उस तरफ से भी शेड हो गया. Now what we can do is, because we did twice wrong but we wanted once, so it can be told like this, that P of I of j minus P of I minus k comma j and minus P of I and j minus k, and we would add what? P of I minus k and j minus k. P of I minus k and P of j minus k. Okay, we can do that. Tell me if this equation is understandable or not. Just tell me this is comprehensible or not. Dekho, the solution to this question is not important. Okay, you are not targeting Adobe. Even if you're targeting, they won't repeat the same question. If they repeat, there is a very less probability. Okay, so you need to have a good understanding of 2D matrix, 2D array sum, so that you are able to solve the related problems too. So the related problems are more important and high probability than this problem itself. Now tell me if this thing is clear. Okay, this thing is clear. Now after this thing is understood, we only want these two equations. Okay, this equation and that equation. Now this question has become very easy. Okay, now what we would do is, we would fill up this element and this element with 0. We did that. So 0 and 0. Okay, then as the currency can be negative also, so what we are doing is, we are taking the minimum integer, minimum negative integer. Shreya, at which point you did not understand? Because we came a long way explaining everything. Just tell me the point where you did not understand, I would explain you the point. Okay, then we are starting from this point, and this point would be from 1. Okay, and I took, see, every time writing x minus 1, y minus 1, this side x minus 1, y minus 1, what I did was, I did x is equal to I minus 1, j is equal to j minus 1, and p of I and j is equal to a of x and y, and this, because this is getting subtracted twice, so we are doing this. Okay, we are building up the prefix sum at this point. So I would just write build. Okay, that equation. Okay, fair enough, I will explaining. Okay, now if we have enough elements to compute the answer, then what we need to do is, we take the maximum out of it. We take the current element, subtract this side and subtract the upper side, and then we subtract the diagonal side. Now let me explain this one again. Okay, suppose this is the given matrix. Okay, suppose this is the given matrix. This is the given matrix, and suppose I stop at this point. Okay, suppose I stop at this point, then the sum would be from this to this, sum from this to this, sum of the whole. This is what we have in the 2D prefix sum. Now suppose I want to take the sum till this point only, and this is k cross k and this is n. Okay, suppose, let me remove this. Okay, fair enough, we want the sum only of this. Now what I need to do is, I need to subtract the sum from this point. If I subtract the sum till this point, then all this would get subtracted. All this part would get subtracted. Okay, now if I subtract this part, okay, if I subtract this part, then all this part would get subtracted. all this part would get subtracted. Now we can see that this part came under this subtraction twice. We subtracted the same thing twice, but we wanted us to subtract it once. So to repay the damage, what we can do is, we wanted it to subtract once. So what we can do is, we can again add this one. So this would be like this. This point is what? Okay, this point is what? This point is P. Suppose this point is P of ij. Suppose this point is I and j. So this point would be I minus k comma j, and this point would be I of j minus k. Okay, and this point would be I minus k comma j minus k. We can do this. So the equation would be like this: subtract this one, and add this one. Okay, now subtract this one, add this one. Now tell me if this thing is clear or not. Let's have an upper bound to this waiting so that we don't need to wait a lot. Okay, so I would just wait for the next 1.2 minutes. Okay, yeah. Now let me know if things are clear to you or not. उल्टा नहीं है. What? Okay. Shreya Satav, it is clear. Chirag Goel, can you tell me? Most welcome, Sanjeev. Most welcome. So that's it for today. Thank you and have a nice day. Meet you on Wednesday. Tomorrow's POD would be taken by someone else, most probably. Okay, that's it for today. Okay, we have 18 seconds more. Still, if you have any doubts, you are most welcome. Else the session would end after this timer has elapsed. And if you have any queries, okay, don't hesitate but ask me on LinkedIn. Just send me a connection request and I would be accepting that, and you can ask the doubt in the LinkedIn itself. Okay, this is my LinkedIn username, Siddharth Hazra.